Welcome to the deep dive. So, you recently shared some really interesting thoughts with us about sustainable practices, especially in manufacturing.
That's right, how important they're becoming.
Exactly. So, for this deep dive, we're focusing on, well, a pretty compelling example, actually. It's about how one major global heavy machinery maker shifted to a closed loop system.
And we're drawing this from a specific case study.
Yes,
Okay.
exactly. It's titled Implementing a Closed-Loop Manufacturing System in Heavy Machinery, CMR, published very recently, April 7th, 2025.
Got it. And your mission, as we understand it, is really to get the practical nuts and bolts
Yeah.
of how a company like this tackles, the big challenges,
Yeah.
material waste, using fewer resources, making things genuinely recyclable.
Especially with all the regulatory pressure.
Right, all that pressure. So think of this as maybe a shortcut to understanding a pretty major industrial shift.
Okay, because the situation they faced, it really mirrors what so many industries are dealing with now, doesn't it?
It really does.
You've got this increasing need to cut waste drastically, use less stuff, design for recycling properly.
And the costs, too. Disposal costs climbing.
Right, the disposal costs, stricter environmental rules, plus, raw material prices all over the place. It's complex.
It is. And their answer, laid out in the study, was this full embrace of a closed-loop system,
Huh.
really putting product lifecycle management front and center.
Okay, product life cycle management. In this context, that means looking at the whole journey.
The entire journey, from the initial sketch, the materials they pick, how it's built, how the customer uses it, right through to its end of life.
And planning for that end of life from the start.
Precisely. Designing each stage with sustainability baked in. It wasn't just tweaking things. It was like fundamentally rethinking how they make machinery, from concept to, well, beyond its first life.
Okay, let's dig into the specifics then. One key strategy you mentioned was designing for disassembly and recyclability. Sounds straightforward, but for huge machines, what does that actually mean on the ground?
Yeah, good question. Because traditionally, heavy machinery is built tough, right? Built to last, often very integrated.
Almost welded into one piece sometime.
Exactly. So the insight here is how they shifted their engineering thinking. They moved towards more modular designs,
Mhm.
standardized components.
Ah, okay, like building blocks.
Sort of, yeah.
Mm.
Imagine interconnected modules instead of one solid unit. That immediately makes it easier to get at individual parts. For maintenance, repairs, replacements, much simpler.
Right, easier to swap things out, but how does that help with recycling at the very end?
Well, by using standardized connections, think common fasteners, common interfaces, they cut down the need for loads of special tools or really complex steps just to take it apart.
Ah, it's
So separating different materials, metals, plastics, whatever, becomes much more efficient and cheaper, frankly. Think about taking apart something with unique bolts everywhere versus standard ones. Big difference.
makes total sense. And the study said this also helps refurbishment, taking out usable parts.
Precisely.
Mm.
Because you can identify and remove modules or components that are still perfectly good for reuse.
Right.
And to make that work smoothly, they didn't just change the design. They also created detailed technical manuals showing how to disassemble things.
Okay.
Plus, they brought in digital tracking for components. So it's a clear roadmap for taking it apart efficiently, maximizing we recover materials and reusable parts. It's planning for that end stage.
That's really thinking ahead. Now, another big piece was using more recycled and sustainable materials. How did they square that with the demands on heavy equipment? The stress, the wear and tear.
That's a critical point. And it comes down to advances in material science, really.
Yeah.
The study highlights their R&D investment here.
So dedicated research.
Absolutely. They weren't just swapping in any old recycled stuff. They were rigorously testing recycled metals, advanced alloys.
Yeah.
Making sure they had the right properties, fatigue resistance.
Like the original virgin materials.
Exactly. Even looking at innovative, biodegradable composites that could handle tough conditions. Lots of lab work, simulations.
So no compromise on performance for the sake of being green.
Not at all. And just as important was their supply chain strategy. They didn't just hope to find recycled materials on the open market.
Right, that sounds risky.
Very. Instead, they built long-term partnerships with suppliers they trusted. Suppliers of high-quality recycled materials.
Ah, securing the supply.
Yeah, ensuring a consistent, reliable flow, which is vital for big manufacturing, right? And it helped manage costs, too. That stability is often overlooked, but crucial.
And the environmental payoff from using more recycled materials must have been significant.
Oh, huge. The study points to a big drop in the impact from mining and processing raw materials. Think of the energy saved, the disruption avoided compared to recycling.
Less digging things out of the ground.
Basically, yeah. And that translates directly to a lower carbon footprint for every machine they made.
Okay, moving on to remanufacturing and refurbishment. This feels like a natural next step from the design and materials choices. How did they actually set these programs up?
Well, what's interesting is they went beyond just fixing things as needed. They set up a formal, large-scale system.
Dedicated facilities.
Yes, dedicated facilities and processes, collecting used machines, components, then rigorous inspection, cleaning, reconditioning,
A whole
the whole 9 yards,
Yeah.
then reintegrating them, either into new production lines or selling them as certified remanufactured units. It's systematic life cycle extension.
And getting those old machines back? They used a customer buyback program. What were the incentives like?
They did. And smartly, too. They offered customers attractive discounts on new or remanufactured gear if they returned their old equipment.
Ah, makes it worthwhile for the customer.
Exactly. It creates a strong reason for them to participate, ensuring that steady flow of used equipment back to the manufacturer instead of, ending up in a landfill. Win-win. Customer saves money, manufacturer gets materials back.
Very clever loop closing there. But when you say remanufactured, how do they convince customers these weren't just patched up old parts? Quality control must be key.
Absolutely critical. The study really stresses the tough quality checks. Remanufactured components have to meet the original performance specs.
Same as new.
Same rigorous testing, same standards. That commitment to quality is non-negotiable for keeping customer trust and protecting their brand. It's about restoring function reliably, giving it a second life.
Okay, let's switch gears slightly. What about waste generated inside their own factories during production? How do they tackle that?
Right, another big piece. They put in place what the study calls a really sophisticated advanced material recovery system. Much more than just standard recycling bins.
Okay.
They invested in pretty cutting-edge tech, including AI-powered robotic sorting systems.
Whoa, AI robots for recycling.
Yeah. And what's interesting there is that the mix of materials and old, heavy machinery parts can vary a lot. So the AI had to be smart enough to learn and adapt its sorting in real time.
So it could identify complex alloys and things.
Exactly. Apparently that was a challenge initially, but the AI got really good at analyzing material properties accurately. These robots can separate different metals, composites, plastics way more efficiently than humans could.
Fascinating. And once it's all sorted,
The key is those recovered materials get carefully reprocessed and fed right back into their own manufacturing supply chain.
closing the loop internally too.
Precisely. Scrap metal from machining gets melted down for new parts, for example. Cuts down reliance on virgin materials again, minimizes landfill waste.
And I saw a mention of smart sensors and monitoring systems in the plants.
Yes, that's about data. These systems give them real-time info on exactly how materials are flowing, where waste is popping up, stage by stage.
So they can see problems quickly.
Right. That data lets them be proactive. Find spots to use materials better, cut waste at the source, make the recovery systems even more efficient. It's all data-driven improvement.
This whole transformation must have required looking beyond their factory walls, though. Collaboration with regulators, the industry.
Oh, definitely. Making sure they complied with all the environmental regulations, present and future, was obviously a huge priority.
So working closely with government agencies.
Yes, and also with sustainability groups, industry bodies. That collaboration was vital to make sure their closed-loop system lined up with global standards.
Did those partnerships bring other benefits beyond just compliance?
They did, actually. It helped them access things like sustainability certifications, which customers value, potentially grants or financial incentives, too.
Builds credibility.
Builds credibility, enhances visibility. And they didn't just listen. They actively participated in industry forums, sharing what they learned, their best practices.
Helping shape the future.
Exactly. Contributing to the industry's knowledge, even influencing future regulations to better support this kind of circular economy approach, being part of the solution sector-wide.
Okay, so we've covered the strategies. Let's talk results. The proof is in the pudding, right? The case study had data validation. What did the numbers show for material use and waste?
The numbers are pretty striking. Within just 3 years of going full steam on this closed-loop approach, they cut raw material use by 40%
40%.
and slashed total waste generation by 50%, half.
Those are massive figures. That must have directly impacted their costs besides hitting sustainability targets.
Absolutely. Direct link to lower production costs.
Mm.
And what about their carbon footprint? Did the life cycle analysis show improvements there?
Yes, the LCA, the life cycle analysis, was revealing. They found a 30% drop in greenhouse gas emissions for each machine producer.
70% reduction. Significant. Very significant. And mostly down to using less energy because they were processing recycled materials instead of digging up and refining new stuff. Plus, the efficiencies from remanufacturing and less waste overall.
So better for the planet and probably lower energy bills too. What did their customers think of all this? Any feedback?
Yeah, the surveys and feedback were really positive. Customers showed a clear preference for machines that were not just tough, but also sustainable.
They valued the longer lifespan, lower maintenance.
Exactly. Those benefits from the modular design and remanufacturing really resonated. And importantly, customers were willing, even eager, to participate in the buyback and refurbishment programs.
That's crucial, shows real market demand.
It does. A growing demand for these sustainable industrial options.
Okay, so customers were on board. The study also mentioned client achievements, looking at the wider impact. What about the cost savings for the manufacturer themselves?
Well, by really leaning into remanufacturing and recovering materials internally, they cut their overall production costs by 25%.
25%. That's a serious competitive advantage.
Huge. Less spending on expensive virgin materials, streamlined waste handling. It all adds up. And like we said, the modular design meant lower maintenance costs for their customers too, adding value there.
Definitely. And being seen as a leader in sustainable manufacturing did that. Open doors, market position.
Oh, absolutely. The study emphasizes they really established themselves as a pioneer in this space. Gained a competitive edge, especially where environmental factors matter more and more.
Getting those certifications probably helped.
Big time. International sustainability certifications boosted their brand reputation, attracted customers, investors, even talent who care about this stuff.
And partnerships.
Yes, this leadership role helped them forge strategic partnerships with other key players, researchers, advocacy groups, even other manufacturers, cementing their role in pushing the circular economy forward.
Sounds like they really set themselves up for the future. And finally, how did this proactive sustainability push help with regulations and risk?
By getting ahead of the curve, integrating sustainability right into their core business, they seriously reduced risks.
Risks of fines, non-compliance.
Exactly. Fines, legal issues, damage to their reputation.
Yeah.
By aligning with and even exceeding environmental standards, they basically future-proof themselves to some extent.
Became a model almost.
Position themselves as a benchmark for what sustainable manufacturing could look like. That means more resilience, more stability in a world that's increasingly focused on environmental responsibility.
Right. So to wrap this up for you listening, we've seen this heavy machinery giant make a really deep commitment to a closed loop system, not just tinkering.
A fundamental shift.
They redesigned products for disassembly, used way more recycled materials, built serious remanufacturing programs, used advanced tech for waste recovery, and collaborated widely.
The results were clear.
Yeah, big cost savings, much smaller environmental footprint, and a stronger market leadership position.
It really shows that embracing the circular economy isn't just, the right thing to do. It can actually drive innovation, efficiency, and real business success.
Which leads us to one last thought for you to chew on. We've seen how it works in heavy machinery, a complex sector. So thinking about that, where else could these core ideas designed for reuse, thinking life cycle, minimizing waste be applied? Maybe in places we don't immediately think of, other industries, our communities, even just our daily lives. Where could we build more sustainable systems using these principles? Something to ponder.